For what values of k does f of x equal to that have a relative max of 10? So what are we supposed to do? What should we do? What's the property of something that is relative, has a relative max? How do we find that relative max? What's the property of something's relative max? On the graph of f, relative max is because it has a slope of what, 0, no? So if we got f, we got to take the derivative, set it equal to 0, f prime of x equal to 0. So f prime of x is what, 3x squared minus 12x plus 9 equal to 0. To find what x value, no, gives you a slope of 0, no, 0. So what would be this x value? So what do we do here? Divide everything by 3 here, and then we get what? So we can factor it out. X squared what? Minus 4x. So it would be what? X what? Minus 3 minus 1. Yeah. So third degree functions do look like a sideways s, no? They look like a sideways s. It's positive cubic. So probably x equals what? X equal to 1 and x equal to 3. So where should it be? Which one is it? 1 or is it 3? 1 because it's the leftmost. You would know it has to, you could test it, no? Do your test if, to figure out which one it is. But it has to be, it is 1. It's 1. And once we figure out that it is at x equal to 1, then what do we do once we know that it is at x equal to 1? What should we do? Don't we already know, okay, if this is x equal to 1, x equal to 1, don't we already know what they're telling you is the maximum of it? What's the max? 10, no? So that's the output going back to here so we can find what k is, no? So the output is 10. And so we're going to do what? F of 1 equals 1 cubed minus 6, 1 squared plus 9, 1 times 1 plus k has to equal to 10. What is that? 1 minus 6 plus 9 plus k equal to 10. So then this is going to be, well, is that 4 plus k? And so k is 6. Yeah? All right, lesson 5.5, using the candidates test to determine absolute extrema. So you got some function that is closed. If you got some f function that is closed at the endpoints, what are the candidates? What x values would be candidates to have an absolute extrema? So the function f has candidates for absolute extrema at its endpoints and at internal critical points. So you would test internal critical points and then the endpoints of it to see which one of those X values has a output or extrema, has the highest or the lowest Y value for it. Let's review. What is the absolute minimum value? What is the absolute minimum value? Absolute, let's see, who's going to do this? It's getting, Crystal, what is the absolute minimum value of that particular graph? Huh? Loud. No, what number? Like no. See, I'm not asking where, or I'm asking what is the absolute minimum value. What is the absolute minimum value? That Rufus, what is the absolute minimum value?
2.
Minimum, absolute minimum. Anthony, what's the absolute minimum value? 1 is correct, I think. You would agree, Tujer? The absolute minimum value is 1, and it occurs at where? At x equal to a, or whatever that number is, 1.2 or whatever, 1.3. The y value is what it is, either min or max, whatever it's asking. So what would be the absolute maximum value? What's the absolute maximum value? 4? The absolute maximum value would be 4, and it occurs at B. A relative minimum. What's a relative minimum value of relative minimum? What would be the relative minimum? Go with we're not a people to ask. Going back over here, Crystal. What is it? What is the relative minimum value? 2. Yes. That makes sense? Relatively speaking, it's lower than anything close to here, no? Anything around this area would be there. And a relative maximum would be what? Everybody, what's the relative max? 4. Okay. It's an absolute max and a relative max as well. Wouldn't this be another one? At what? At 3, no? So yeah, it would be this one because it's inside. It would be relatively a relative max, and also it's an absolute max. But this one is a relative max, but it's definitely not an absolute max. It's a relative max. All right. So you got to know the difference between what's given. And this is absolutely important of knowing that that's f, and this is f prime of x. That will give you different information because the second one is a derivative function and the first one is a position function or something like that. All right. So let's go ahead and figure this out. The function f prime of x has candidates for absolute extrema at its endpoints. Okay, at its endpoints for sure. And where in this particular one? Is this a critical number or critical point, interior critical point? Would this be an interior critical point? No, these are not it. Because this is the derivative. And where it changes, see, this is the derivative. Wherever the slope changes from negative to positive, yes, or from positive to negative, those would be it here. See the difference between that one and this one? So then, at endpoints, and at what are they called? Are they called interior critical points? What are they called for f prime? I guess they are called interior critical points as well. But they are not located at the same spots as f. All right, moving on. Here we go. Let's do problem number 1. That is a lot of writing right there. Let me give you what is this? 7 minutes, 5 to 7 minutes. Copy this down so we can do it. It's only us. Town's getting smaller and smaller. We'll go again with this. We'll go. Who's gonna go here? Crystal, let's go. Come on, Crystal. Go up there and we're all gonna just talk about it. Get that pen is up there. Right there, the pen. The graph f prime. So we know that this is the derivative graph. Derivative graph is shown. Okay, whatever. On what values of x does f of x have a relative maximum? The function. Okay, what do you put there? What do you think goes there? The function f prime has a relative maximum. Everybody, is that correct? The function f prime has a relative maximum. Is that correct to go about it like that? See, we don't have the f function. We have the derivative of f, but we wanna what is that? Deduce or come up with what f looks like. So it is not f prime. It's talking about f. So the function f, which we don't have, has a relative maximum at. Now by looking at this f prime graph, we can figure out where is the relative max. Yes or no? So where is the relative max at? Rufus, what do you think looking at that graph? Where is the relative max at?
-2.
At -2. Interesting. Put a dot at -2. Put a dot at x equal -2. X equal -2. No. Step back. Where are you at? Now, why is it -2, Rufus?
Because f changes from positive to negative at that point.
Because, okay, hold on, look. Because f prime changes from positive to negative. Or we could have said that f changes from increasing to decreasing. Is that making sense? Because it depends on what are you talking about. Are you talking about f or are you talking about f prime? And if we are talking about f, the function f has a relative maximum at x, which is correct, no? Go ahead and put your x equal -2. At x equal -2. Because whatever, this one is up to whatever you want to do. You could say because what? We could say f prime, go ahead and put your f prime. You see how that because changes depending on what you want to do? Because f prime changes from positive to negative at that point, no? Or you could have just said because f changes from increasing to decreasing. That makes sense now. So go ahead and put down because f prime changes from positive to negative at that point. All right, let's go to B. On what values of x does f of x have a relative minimum? The function f has a relative minimum at x equal to what, Anthony? Loud.
7.
At x equal to 7. Go ahead and put a relative minimum at x equal to 7. Because, here's the because. I guess we could just stick to f prime, no? Because f prime changes from what to what? Negative to positive. Good. That should be good, I think. F x equal -2 because f prime changes from positive to negative. F, x equal to 7 because f negative to positive. Yes, good. Yeah, this because you be very careful with that on the AP when you take it, and that's have a good reason for that. Number 2, and they actually make sense. So it says here, find the absolute maximum and minimum values of the function f of x equals that on this interval. It's closed interval, so we do have to test those endpoints. If for some reason they give you open endpoints, then you don't test those open endpoints, you would just test the inside. But since this is a closed interval, you have to test those outside and those inside critical numbers. So to find those inside critical numbers, we take the derivative, set it equal to 0, and find those inside critical numbers. Or x values, 3x squared minus 6x equal to 0. Factor out 3x. X minus 6. X equal to 0. X equal to 6.
X minus 2.
X equal to what? X equal to 2. So these are the inside critical points, no? So you test it. You could do a table. Just do a table and put those the numbers, -1/2. Put 4. Put what? 0, 2. And if you had a calculator, like again, we gotta speed it up. Just save this in a calculator and do f of those, and then just see which one has that. All right. Whatever. Okay. So there. Put in the calculator, and so find the absolute max. So where's the absolute max? At x equal to 4, and it's 17. The absolute max is 17. The absolute min is at x equals 2, is -3. And this is what it looks like. Probably this is not a good way to give that information. Probably you want to say absolute max occurs at x equal to 4, and the absolute max is 17. Probably they're going to have a problem just saying that's where it's at. So the absolute max is actually 17, and it occurs here. And absolute minimum is -3, and it occurs at x equal to 2. Let's go to number 3. position of a particle traveling along a straight line is given by this position function on this interval. When on the interval from 0 to 10, including 0 to 10, when is the particle farthest to the left? Farthest to the left is, okay, so this is a cubic function, third degree function. Third degree function would go like this, and probably would be the second number when you, if, that's if, because this is, say, something like that, so this is x of t. It'll probably be the where it changes direction here. So it'll probably be the second number. We're gonna take the derivative, but we don't know. We gotta still test even the endpoints. So all right, let's x prime of t. Plus 15. Factor out the 3, I guess we'll do it like this. And t squared minus 6t plus 5. And then this is going to be what? T. What is that? Minus 5 minus 1. So t equal to 5, t equal to 1. You still gotta test all those. So again, get a calculator and just test all those. These are all candidates. 0 and 10 and 1 and 5. And then plug it back into this function, this position, to find when is it the most negative out of all the low would be it, no? Or whatever, the furthest to the left on the number line. So it is going to be at x of 5. Farthest to the left. All right, let's go. Let's go. This last one. Let's go number 4. A particle moves along the x-axis so that its velocity from 0 to 5, not including 0, not including 5, is given by that. Yeah, I had said earlier that if it's not included, to not test it, but even though that one is not included, you have to test it. That's the crazy thing. I got a problem with that, not including 0, not including 5. We can't test it. We should test it. What do we do? What's step 1? Take the derivative, because we still got to do some minimum velocity. You try to take the derivative. So we take the derivative, and it's going to be t squared minus 6t plus 8 equal to 0. Man, is this a typo? It should have equal to test those endpoints, even if it's not included. Oh man, is this a typo? I'm going to say that this is a typo. Put equal. Yeah. I gotta go look where I got this from. But it has to have equal. All right, and then go to. And so, what is the minimum velocity of the particle? Occurs at t equal to what? 0, and the minimum velocity is -5? We'll stop here. That is it.